So the first free response question is, let f be the function given by f of x equals 2x e to the 2x. And I'm doing part A, which is to find the limit of f of x as it approaches negative infinity, and then find the limit of f of x as it approaches positive infinity. So the first step is to, of course, rewrite your limit. Negative infinity of 2x e to the 2x. So I'm going to treat this function as two different equations. So you have to plug in negative infinity because x is approaching negative infinity. So 2 times negative infinity is negative infinity. And e to the 2 times negative infinity. You know, 2 times negative infinity is negative infinity. And e to the negative infinity is 0, because on the graph, So, since we know that e to the negative infinity equals 0, you can bring it down and place your equal signs. And negative infinity times 0 equals 0. So, the limit as x approaches negative infinity is 0. So, for the limit as it approaches positive infinity for 2x e to the 2x. And do the same thing that we did up top, break it apart, and then now you have to plug in the positive infinity, and just going to shortcut it. 2 times infinity is infinity, and e to the 2x times, the 2 times positive infinity is infinity, so e to the infinity is also infinity, and infinity times infinity is infinity, and that's your answer. Okay, so today we're going to solve this AP question from the AP Calc exam, and it is f of x equals 2x minus x squared when x is less than or equal to 1, and then x squared plus kx plus p when x is greater than 1. And the question is that we're trying to make the f of x continuous and differentiable at x equals 1. So to make it continuous, limit as x approaches 1 from the left side, which will be the 2x minus x squared part, has to equal the limit as x approaches 1 from the right side, which is the x squared plus kx plus p part, okay? And then all you're going to do is you're just going to plug in this 1, direct substitution, and it would be 2 times 1, which is 1, minus 1 squared, which is 1, so that would just equal 1. And since they are supposed to equal, you just plug in that 1, and so this equals 1. And so when you plug in the 1 for here, you get 1x squared plus k times 1 plus p. So that equals 1 plus k plus p. Now, since we are making it continuous, and this is a polynomial piecewise, the left and right derivative also exists. So we would take the derivative of this, which would be 2 minus 2x, and set that equal to the derivative of this, which would be 2x plus k. Okay. And so these should equal, so you just plug in that 1 to make it continuous, so then you get 2 minus 2 times 1, which is 0, and then you get 2 times 1 plus k, which equals 2 plus k. And so just to solve for k now, we would just get negative 2 equals k. And then you can plug all that back in for there to find what p is. Since all this equals to 1, you get 1 minus 2 plus p equals 1. And then you subtract your 1 and add 2, so you get p equals 2. So to make the function f of x continuous at x equals 1, k would have to be negative 2, and then p would have to equal 2. Okay, so this is our last free response question of the day, and they gave us a chart that shows the values of f of x and f prime of x when x is negative 1.5, negative 1, negative 0.5, 0, 0.51, and 1.5. Now our question is asking us, well, the question is giving us the function g of x in a piecewise function. And it's telling us, it's asking us if g of x and f of x are the same function. This is the function, the g of x, as it approaches 0 from the left. So, the limit of x as it approaches 0 from the left. And this one is a function of x as it approaches 0 from the left. I'm going to make the exact same graph that they have on the calculator to show that these functions are the same. So I rewrote the functions, and I'm going to rewrite these x values on this side. Negative 1, negative 0.5, 0, 0.5, 1, and 1.5. So in the calculator, it was the exact same values: negative 1, negative 4, negative 6, and negative 7. And you stop at 0 on this function, and on the other side, where we begin at 0, so just go straight across, and that negative 0.5 is negative 6, and that 1 is negative 4, and then 1.5 is negative 1. So it is the same values all across. Alright, so Janaya just showed you all that g of x and f of x are the same function. And since the graph that they gave, since the table that they gave us also shows f prime of x, we're going to check g prime of x to make sure that they're the same. Also. So I'm going to erase this part. Ooh, maybe I shouldn't do that. Okay. So g prime of x equals 4x minus 1 and then 4x plus 1. And so I also plug those values into the calculator, and so you can't see the calculator, I'm just going to recreate the graph on here, the table on here. So G prime of X, and then we're going to, yes, okay, let me erase that, I'm sorry. So you got negative 1.5, negative 1, negative 0.5, 0, 0.5, 1, and then 1.5. Now these are just the X values that are across the top. And when we're going from the right-hand side, from the left-hand side, we're using the f of x minus 1 function. And so for negative 1.5, you get negative 7, which is exactly what you get up here. And then for negative 1, you get negative 5, which is exactly what you have for f prime of x. And for negative 0.5, you get negative 3, which is exactly what they have up here. And then we're going to do the right-hand side, which would be f of x plus 1. For 0, you do not get the same value as you have for f prime of x. You get a negative 1 instead. But for 0.5, you get the 3, and then for 1, you get a 5, and then for 1.5, you get a 7. So everything is the same when the limit approaches 0 from the left-hand side and from the right-hand side. The only difference is when we are exactly at 0, because for g prime of x you get negative 1, and for f prime of x you get 0. And this means that the function is not the same.